Sounds good. Thanks, Conrad. Good afternoon, everyone. So as Conrad mentioned, I'm Christian Link. I'm one of the CFD application engineers here at RAND Simulation. So just to start us off here, as a friendly reminder who RAND Simulation is, we're an elite channel partner and simulation consulting firm. We work with ansys products and we support a variety of different physics. So whether your needs are fluids related, mechanical, electronics, optics, whether it's training, collaborative consulting, or getting ansys products embedded in your company, we're the ones to call. So if you have any questions, as Conrad mentioned, feel free to drop them in the chat, or if you have any other questions related to getting ansys products within your company, please feel free to reach out to us and we will follow up with you after the webinar. So without further ado, moving into starting us off with our agenda, right? So just kind of walking through today's presentation briefly, we'll start with a brief kind of historical look of product validation, where it began, how it evolved, and then afterwards I'll briefly cover some common objections that you may often hear regarding simulation and what those benefits are of actually implementing simulation within your corporate ecosystem. We'll get into some details within a sample case study. We'll see how simulation can actually optimize more than just your engineering organization and actually cascade benefits throughout the different business units. And then moving into a little bit more of the strategic aspect of, how you can leverage simulation tools outside of engineering for whether it be market share improvement, competitive benchmarking, things of that nature. All right, so the historical background of validation, kind of where we all started, right? So moving from left to right, we've evolved within the product development world and engineering as a whole, right? In the beginning, it started with trying something out. So here we're thinking of whether it was the automobile, airplane, first of their kind products, right? People didn't know what they didn't know at the beginning. So it's just kind of pioneering those processes. You don't have anything really to start with, but the more that people worked with these products, they became the specialists in the field. And so then there was a lot of leveraging of tribal knowledge as it was created. There was these centers of knowledge bases in certain companies, right? There wasn't any common database, standard processes, procedures. It was all kind of in development as that went. And then moving one step further, we started to get more organizationally intelligent using physical testing. So now we're actually using some upfront testing to make sure that our product behaves as we designed it to be before it gets into customers' hands, right? So this gets into starting to prevent, whether it be warranty claims, ensuring the product is robust as we promised our customers, things of that nature, right? So the big shift here from going from an initial design launch mentality is now there's this feedback loop that we can feed back into design. So as our design engineers are developing the products, that there's this catch, right? Before we launch the products into the wild, we're making sure that they're robust enough, right? So now we have this expense that's embedded in our business, right? In terms of overhead, we've got some, whether it's prototype materials, prototype tooling that we have to embed, but the cost was worth the benefits that we would gain, right? We have a lot more leeway into what our product is going to do once it gets launched, right? So now we can actually start to build some technical knowledge, but at the end of the day, it's still very reactive, right? And then with simulation coming along, now we can get very much proactive and start front loading our design process. So when we're front loading a lot of that, we're talking about doing a lot of these simulations even before we cut prototype tools or any kind of tooling. No materials are required physically, right? It's all computer driven. So now a lot of cases, what we're seeing is real-time results compared to physical testing, right? An engineer can run a simulation, make design tweaks in CAD even before we're ready to move into tooling. Some companies nowadays even do upwards of 98% of their design validation work all digitally. So using simulation and then using physical testing to kind of close that loop, whether it be for special certifications, things of that nature. On top of that, it's cheaper, right? Envision having to make aerodynamic tweaks to a Boeing 787 in the physical realm or making subtle tweaks to F1 race cars. It gets really expensive, and having simulation as that option to fall back on or becoming the front leader of design, that's incredibly helpful and lowers the business's overall, cost impact per product line, per project, etc. So now we've got this computational capability that gives us really useful information to feed back into physical testing. Now we're shifting that mindset of, I'm kind of confident in the product launching the way I intend it to go, to now I am confident and I know if there are risk areas, it's in one of 2 or 3 separate locations, here, here, and here, that you can pick them, right? So even in the event of physical testing where you have to retest, you know where to look. It's not a huge fire drill to start redesigning from that perspective. Here we're focusing on mitigating that uncertainty to such a high degree, and we're starting to reap that benefits cascade throughout other business units. So then what happens when we combine physical test with simulation together? So now we've got this really robust product development cycle. We're proactively designing and minimizing the reactivity in the test cell. It's very much a in-tune product development organization. This is the pinnacle of product development. Can utilize all the capacities in balance, right? Your physical test organization isn't overloaded from a lot of repeat testing. They can be focused on really high profile projects and products. And then at the same time, analysis can really reduce that front end design time up front. So now we can shorten our overall timelines, overhead for products. All these things start to really roll into all these different benefits together. All right, so then what are the common objections that we so often hear with simulation? What's kind of the word on the street when people start hearing simulation? What are the detractors to simulation? A lot of these common reasons to not embed simulation in an organization are really focused on this comfort mindset or this comfort effect, right? If it's not broken, why should I fix it? A lot of these changes cost money. Why should I sink more money into something if I don't have huge warranty claims? A lot of times, some people will have an adverse reaction to increasing the overhead with this. We're already doing physical testing. Why should I add another layer on top of this, right? But when we're thinking about the market as a whole today, even beyond our company, being good enough is not good enough in such a competitive world, right? We've got so many lower cost competitors. Even if their quality isn't the same as our product, there's still that competition. Customers may not know that our product, whether that be, a widget, what have you, is potentially better than, company B's widget at the same time. So when we get into that in greater detail, you can't rely on legacy customers to keep paying premium prices if your product isn't moving along at the pace of the market or exceeding the pace of the market, right? At the end of the day, working through it, keeping up with this, and really building and bolstering your product development cycle is really important. So now the converse to that is, okay, those are all the reasons why I shouldn't, but why should I have simulation now? So more efficient R&D, first and foremost, this is going to be the one that you'll hear most frequently. So I've got this example here up front of just a sample physical testing and timing cost walk. Really basic. We've got, a couple of physical tests here. We're broken it down to engineering labor, how many test engineers, what's their hourly billable rate, how long it takes to really process the data for creating results, that prototype material cost, because if we're going to test it in the physical test cell, we need, physical prototypes. In some cases, those can get very expensive, right? So it's important to take into account when we're doing this cost walk, all the different sources of costs, whether it's from, salary, overhead, material costs, timing, all of those really feed into the total business case of how simulation can really help reduce the overall development costing of what we have here. So in this model here, in this example, we've got 3 physical tests. All the math shakes out to about, $17,200 each. And then we've got our total cost for 3 of those tests, $51,600. So note that this also includes the material costs, the labor, and then at the very end, this test plan, as we see it, is taking 18 days to walk through. So now if we take a look and go, okay, I want to add this pipeline of work, of simulation support now. So now we take a look at it and go, okay, what if we reduce physical testing by one physical test, right? Instead of testing this product 3 times, we're doing it twice instead. And it's a very conservative estimate, right? Sometimes you'll find simulation can reduce the number of physical tests quite significantly. But for this example, we're trying to keep it realistic, keep it what you would kind of expect on a conservative end. So now as we look at analysis front loading, even though we're adding a couple days up front and there's this additional cost, we're saving that on the back end here. Work is cheaper and it's lower risk in the simulation space. So this in turn leads to more certainty of the outcome of physical testing. You know, having those design engineers have that certainty or reduced heart palpitations getting to the physical test cell, knowing, okay, you know, I have designed a robust product. I have a high degree of confidence that I'm going to test this, I'm going to pass it, and I'm going to meet my project timing. That's incredibly important of what we can do with this. So now with this revised, you know, layout of workflow, now we're looking at total costs that have dropped to $36,800, and our total test plan has dropped to 11 days. So the big take-home point here is we've just decreased 29% of our validation costs and decreased the overall timing to do this validation activity close to 39%. Right, so this is, we're trying to get rid of all the re's of project launches, right? Redesign, retool, retest. Analysis is helping drive those extra bloat out of our process, right? So now you can start to see, okay, now I have all this flexibility of what I can do with all these extra resources. You know, how can I now redeploy all these test engineers to work on other high potential products? It's a lot of time and cascading benefits that you can save with this. So now going into more detail of what that looks like, you know, after we implement that, we're looking at this kind of repeat process here, right? So starting with more simulation, each revolution around here, around this pie chart, we're getting a faster and faster product launch, and we start to really compound the benefits here, right? You're making these iterative changes within your organization, not just engineering, but then you're focusing more on each of these product launches, right? So if maybe this product A, we're saving 2 days, right, conservatively. Maybe on the next one we go, okay, we have a redesigned product that's an evolution of what we ran today. Maybe now we can save 6 days or a week or 10. Same thing with costing, right? You're fundamentally shifting how your product development cycle and organization is thinking about launching products as a whole. Each step is building on the last, so the benefits keep cascading into new product launches. So here we start to see the whole business begins to reap the benefits, right? Now, if our product is getting out to market a lot quicker, that means it's got more time to be on the shelves, potentially even before our competitor gets onto the shelves, right? Quicker to market, more time on shelves, quicker than competitors, more dollars at the end of the day. We're creating a larger customer base, a more loyal customer base because they have more exposure to our product compared to others. That's that passive benefit that we're starting to grow in, right? That's that passive revenue income, so to speak, of the business, right? On top of that, within our technical organization, our engineers are getting smarter. The more analysis that they do, they start to see how different designs behave in reality, right? They start to go, okay, this design cue works for me in all my past project lines. I should incorporate that into this one. Or if they're working as part of a team during design reviews, maybe it's taking a look and saying, okay, you know, we've experienced this hang up before with this particular material or whatever. This really reduces our fatigue life. Maybe we should change that, right? All of this starts to get more intelligent design practices into the hands of your engineers. So then it's going to result in less cleanup later when we're talking about those retooling, redesign, those aspects that slow down the product development in here. Ultimately, when we're embedding analysis in our product development cycle, we're really reducing those sprints and spike events of labor usage, right? So as your strategy team or strategy organization, product development organization starts to load the calendar year with different product launches, you don't have these big events where, okay, I'm dedicating half my engineering force to, you know, 3 of my 10 product lines, as opposed opposed to making sure, okay, my loading is more balanced, and it makes it more predictable for overall budgeting year to year, not just head count, but materials, timing, testing, all of that starts to build on itself. All right, so shifting gears, now we're going to move into more of this strategic marketing aspect, right? So what else can simulation be used for besides within just engineering typically, right? We're talking about competitive benchmarking on this example here. So me as a customer, if I'm buying something, I want to know how it performs against competitors. A lot of cases, the average consumer, this is most common for, automobile purchases, right? If you're buying a Honda or a Toyota or a Ford, how does it compare against Chevys, Hyundais, et cetera? Is it really going to live up to the claim of, does it really get 50 miles per gallon? Is it the most durable product in the space? If I have a product, whether it's I don't know, a chainsaw or a refrigerator or whatever, is it truly 25% more efficient in the industry, or is it the top competitor? Simulation has that unique ability to tailor that message to the customer's needs against its competitors. The big question I have there on the right in blue, is your product better than the competition? Show me. With analysis, you're able to show customers that in not only just how yours performs, but side by side to others, right? Visually, you can ground your assertions in data, in math, and be able to say a lot of this with confidence, right? So an example here, our product performs 42% better than the market leader according to the standard industry life cycle test. That's a lot more powerful of a statement compared to our product has best in class performance, right? I'm not getting a lot out of that first statement as a customer. So with that, the side-by-side comparison, same conditions driven by math, that helps build that trust with your customer, right? They're taking a look at this and going, okay, this company actually cares about my usage in the field, how I'm using the product, right? And so carrying through this mentality of repeatability. So I'm sure a lot of you have heard the, as seen on TV ads. I think the one that, kind of makes me laugh the most is the spray adhesives for turning screen doors into boats, right? Oh, it's completely waterproof. Look, we tested it. Well, how was it really tested? How was it really controlled? A lot of that is hidden behind the curtains, and we can't really see a lot of that, right? So some things we just can't control in physical testing, and that's an error that could compound within our assertions that we're making, within our data, communications to customers, marketing, et cetera. But with simulation, you can address some of those uncertainties and you can take more control over that uncertainty, right? A lot of these, did your supplier create the right prototype? When you're asking your supplier, hey, I want, 5 copies of this version of the product for testing, are those tolerances matching up with the print that you requested them to manufacture? In terms of fit and finish, in a lot of cases, sometimes prototype materials aren't done to the same spec as production. Same thing with prototype tooling. Maybe that tolerance isn't as tight as what you would truly expect. With analysis, you can ensure, as it's designed in CAD, that's how it's going to be simulated. Exactly. Here's the materials, specifications that I'm loading into here. We're dictating that consistency in the data collection. If I want a thermocouple or a pressure transducer, in this position, that's where it's going to be because I'm telling the software where that needs to go. All of this makes for a more powerful and robust story that you can tell with your customer through all these different customer touch points, trade shows, marketing materials, launches, things of that nature. So now the obvious piece is the visual impact of it all. So this is kind of a fun one that I think analysis doesn't quite get a fair shake at outside of engineering, right? There's a lot of power in the visual aspect of it. So one of the common things that we look at, I like to make the comparison of, physical test is the finale, right? And simulation is the whole movie. We're able to see how that product is performing throughout its life cycle, or if it's a drop test, a thermal loading test, in reality performing over 2 hours of maximum load runtime. How is the system changing throughout that process? versus within physical testing, we break it, we test it, we go, okay, either the product works or it broke here, and it could be a variety of failure modes, right? With simulation, you're actually seeing, this is how it broke and the likely causes, or in the more favorable aspect, this is how your product is working throughout the life cycle. And that helps to, really show customers what is really going on behind the scenes. A physical test can't show water flowing through a network of pipe really easily, right? You can do a bunch of cutaways and things like that, but how is that actually mixing in there? How is our product being mixed in, say, a fermenting tank in the beer brewing industry? What does that really look like? A lot of that visual horsepower is really important to share with our customers that can really augment the message for them to buy our product. These insights are what really educate your customer at the end of the day. Going from, going into the store, purchasing the product, this is that additional middle ground that helps them build the case to justify a purchase for our product. It's showing that you're doing your due diligence and you're accounting for their various use cases, and it's communicating, subconsciously to them, I fundamentally understand how you are using this product, and I am designing my product to meet it exactly how you'd be using it in your environment. It's creating better products that drive customers to be more brand loyal to you at the end of the day. And so this is a very simple slide, right? Seeing is believing. I wanted to finish out this presentation to really show you with that visual, aspect of simulation. These can tell amazing stories. Pictures are worth 1,000 words, as everyone says, right? So these images we've got on the far left, cooling fans on server racks. How is that air actually being vented into the system and out of it? The middle picture here, how is air being distributed throughout a room? Where is that airflow going? On the farthest right, how is a substance or species being mixed within a tank, or a certain concentration of that? This is that visually powerful message that can really help sell customers to buy our product, that we didn't just launch it in a vacuum with our test cell or close off, right? We're actually doing our due diligence, going through the paces, and giving your customers a window into how a product can behave even before it reaches their hands. That is an incredibly powerful marketing tool. So on that note, before we shift into questions, I want to once again remind all of you that if there are any questions regarding follow-ups with product requests, consulting, training engagements that you're curious about, we'll make sure that we reach out to you, as Conrad said, after the webinar presentation. Feel free to reach us at the contact information listed above. And at this point, Conrad, we'll shift it over to questions.
Sounds good. Thanks, Christian. And just as a reminder, this has been recorded, so you'll get a copy of it here in the next couple of days. And if you have any questions, feel free to type them into the questions panel, and then I will ask them. I have a couple here, so let's just get started with the questions. Let's see. My supplier already does my simulation. What benefit could I gain bringing that work in-house?
That's a great question. So with that, when a supplier does that, and I totally understand where that mindset comes from, right? We're already paying a supplier to do the work, and hey, if we can offload that extra work to our supplier, that's fantastic, right? That's dollars saved. But with that, you give up a lot of the transparency to how those simulations are done if you were doing them in-house, right? We don't have typically the visibility to how those models are set up from a supplier's perspective, right? They may issue a final report and potentially give you some insight into how the model was set up, but there's still a lot of questions that could be missing, right? And some of the assumptions that were made for that analysis may not be something you're comfortable with taking on in terms of risk, as opposed to if this was done all in-house. Another key, benefit to bringing it in-house would be sometimes the turnaround is incredibly faster, right? If your supplier is on the other side of the globe, or a couple time zones difference, as opposed to having that capability in-house that you could say turn around a fresh analysis in a couple of hours, as opposed to waiting for a new business day, the request being navigated through the supplier's workflows, et cetera. It's, again, a huge time savings and bringing in that capability to truly understand how the product is made. And even on top of that, the ability to check suppliers, right? So that you can see their prototypes or how it's designed and say, hey, why did you design it in this way? It adds an extra layer of oversight on top of your suppliers.
All right, thanks, Christian. We had another one come in earlier here. I can just answer this one. Someone's just asking, will you get a PDF of these slides? Yes, we send out the recording, and I can get you access to the PDF as well. So we just had that one come in. Another question in here is, in your example about simulation versus no simulation, dollar and time savings, wouldn't there be more benefits?
I'm sorry, finish that thought, sorry. Would there be more benefits?
It just says, in your example about simulation versus no simulation, dollar and time savings, wouldn't there be more benefits?
Understood. Got it. Sorry about that. Yeah, no,
Okay.
absolutely. With that, this was just kind of, I can jump back to that slide here so that we can kind of see what that looks like. So with that, absolutely, there'd be some other benefits here, but this is just taking a very small example. On top of this here, what I would envision as well is a lot less design engineering time spent upfront, right? If we're already leveraging simulation, that's going to be less design time, whether it be a couple days, couple weeks, if we're outsourcing that CAD work to a third party, right? That's going to be time save and dollar save. And even, again, if that particular CAD vendor supplier is overseas, there's a time save with that. On top of that, for project budgeting, right, it's going to cascade into getting these assets, whether they're simulation engineers, design engineers, test engineers, redeployed onto other product lines with that. Moving more towards less reliance on suppliers, right? Maybe it's moving to suppliers that don't have in-house simulation, right? That maybe our current supplier does, and they use that as a huge perk for us to stay with them, but maybe that's embedded in the piece price of what they're offering us. So if we shift to a more domestic supplier and we say, hey, we're willing to take on the simulation for it, that's less money that we as an organization have to spend. Adjusting headcount, being able to launch products or take on more product revisions faster. It's a lot of those benefits that start getting at market leadership, best in class behavior, things of that nature.
Alrighty, it looks like we just have one more here. I have the software, like the ansys simulation software, but not sure what to focus on first for the greatest return on having the software. Any recommendations to get started?
Sure, that's a great question. With that, I would be focusing on the low-hanging fruit, right? Where I have a lot of projects or products that have launched with a lot of retest, right? A lot of high cost, high time, delays, physical test failures, et cetera. Those would be a good place to start hacking away at, going, okay, if I can reduce the material spend even by, a couple $1,000s, couple tens of thousands of dollars, depending on what scale of prototype costs you're in, right? Some companies have really large material costs, others do not. On top of that, even taking a look at very robust products that are legacy products that have been in your pipeline for a while, that you can create models of and sample validate them pretty easily, right? Having that data set is really important to do. Another great place to take a look at would be doing A to B comparisons, right? So in a lot of cases for new products, maybe a design engineer is tasked with creating 3, 4, 5 sample designs, right? That maybe they're trying to vet out, but don't know which is going to be the best to move forward in the product design process. So here, using simulation, you can do a lot of what are called A to B comparisons, where you're testing your different designs for a certain criteria. Maybe it's fatigue or temperature, things of that nature, and you can quantify, okay, this particular product behaves, 25% better. Maybe it's got a 30% lower skin temperature as opposed to design A, right? So you can start to knock out a lot of these alternative designs that would drive cost as you're launching that product downstream.